Hey all, so we're going to keep working with Taylor and Maclaurin series. As I said, one of the big uses of these is to solve problems that you really just haven't been able to solve before. You'd have to use your calculator or use some, just give up. And I want to show you a problem where you are going to want to use the Taylor and Maclaurin series to solve it. In this case, this integral here. And then what we're going to do is do a little bit of calculator practice, and you'll have a nice problem set to work from for homework. So get yourself ready for notes, and we're going to get started. Now, for problems like this, both in the homework today and the way that they will appear on the AP exam, there's just going to be some that you want to have memorized. Now, there's some Maclaurin series already that I've told you in the past you just want to know. And the first one is e to the x, which is the series from 0 to infinity of x to the n over n factorial. You can also see it written out as 1 plus x squared over 2 factorial plus x to the third over 3 factorial, and so on. We had it in the notes as well as 1 over n factorial x to the n. Those are equivalent. The other two to have memorized is sine of x, which hopefully, as you remember, are the odd alternating terms. So we have the alternating, negative 1 to the n, over the odd numbers, so 2n plus 1 factorial, x to the 2n plus 1. And if you wanted to expand that out, you'd have x minus x to the third over 3 factorial plus x to the fifth over 5 factorial minus x to the 7th over 7 factorial, and so on like that. So odd, even. Sorry, not odd, even. Positive, negative, all the odd terms. Last one I had you just work on memorizing is cosine of x, which are your even terms. So from 0 to infinity, alternating still, and then it's 2n factorial x to the 2n, which if we wanted to write it out would be 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the 6th over 6 factorial, and so on with the alternating even terms. Now there's one more I would love to add here. As you can imagine, we've got sine, cosine, e to the x. If we've got e to the x, we're going to memorize the Taylor polynomial of ln of x. And if you want to work it out, you can by hand. I will tell you right now that this is the series of it's n equals 1 to infinity, and it's Taylor because it can't be at 0. So we're going to say centered at x equals 1 because it has a vertical asymptote at 0. And if you center it at x equals 1, this becomes negative 1 n minus 1 over n, not n factorial, just n. If you wanted to do the math, work it out, you'll notice that it creates, that the derivatives of ln create a factorial, which cancels out, like what we saw in the last example yesterday. And then x minus 1 to the n. And this is why we start at 1, is that if I plug in here, if I plug in 1 here, it becomes 0. So you can start at 0 here, but the first term of this series is ln of 1, which is 0, and that's the only reason that that starts at a slightly different point. And centered at 1, so we see that. So these are the 4 you want to have memorized for the AP test, and these 3 are going to be helpful for you for every calculus and math class you go. ln shows up less frequently, but it's still nice to have, and it's certainly nice to have on an AP test. So here, number 1, find the integral of e to the x over x dx. Now, when you look at this, try parts first. And if you want to challenge yourself and figure out why it doesn't work, feel free, try parts. Most of the time, that will work. Now, it is, of course, in this case, not going to. I'm going to warn you that now. And so that means if parts fails on an integral where you have multiple sets, then this is the time that you might think to use Maclaurin/Taylor expansions. Now, there's a couple of criteria you want to meet before you start using this for either derivatives or integrals. So the thing that you want to start with is all other methods failed. Because this is definitely a trickier method, and you don't necessarily want to jump right into it if something else is going to work. So all other methods have failed. It involves your known series. So one of these four that you see, right? If it doesn't involve one of these four, or it's not given in the problem, so either e to the x, sine of x, cosine of x, or ln of x, / it's just given. So sometimes you're going to see an AP question that's like, if, it'll say f of x over x, if the Maclaurin series of f of x is this thing, then okay, well, I'm definitely going to use Taylor or Maclaurin here. And then the last criteria is that it also wants to involve terms x to some power or x minus a to some power. And if you have all of those criteria met, it's like, okay, let's try that. Now, the first step when you recognize I want to try Maclaurin or Taylor is write out the functions as their series. So in this case, we see e to the x. So e to the x over x dx, if I wrote it out as its series, is 1 plus x squared over 2 plus x to the third over 3 factorial plus x to the fourth over 4 factorial, etc. And then this denominator doesn't have a series, it's just x. Now, the next thing we want to do is what you'll realize you're on the right track for your next step is that you can simplify. If you can't simplify at this step, you're like, okay, probably jump the gun a little bit, don't want to use that strategy. In this case, though, you can separate out all those terms and divide by x as you would. So this becomes 1 over x plus x over 2 factorial plus x to the x squared over 3 factorial, because we're just dividing out an x from each term, x to the third over 4 factorial, etc. Now, because it's now a nice polynomial, then you just want to solve. So in this case, you're going to integrate for this problem, but you could also keep differentiating if it's a differentiable problem. So here, 1 over x is ln of x plus 1 plus x squared over 2 factorial times a half, so I'm just going to put times 2 in the denominator, plus x to the third over 3 factorial times 3, plus x to the fourth over 4 factorial, 4, so on and so on. Now you can leave it like this. You'll probably notice is that some of these terms just simplify very neatly. So you might see your final answer written as ln of x plus 1, and then the series in this case of n is starting at 2 to infinity of x to the n over n factorial times n. So you might see either of these two answers written in that place. And this is, again, one of the few places where you actually really want to use your Taylor and Maclaurin series. You can also use them here for estimate the integral to 2 decimal places. Now, I want to just make sure that we're practicing both strategies for evaluating integrals and then series on our calculator. So please do practice both of these, because obviously you can type this into your calculator over x dx. And if you type this into your calculator, we want it accurate to 2 decimal places, right? You go math fn int, and then type this in. You should get 3.06. I do want to practice with you with your series as well. So since we know that this is the integral, we also know that the integral here from 1 to 2 of e to the x over x dx is equal to ln of 2 plus 1 plus the series 2 to the n over n factorial n equals 2 to infinity minus ln of 1 plus 1 plus the series n equals 2 to infinity of 1 to the n over n factorial n. So we're just plugging in that term to our functions here. And then what we will end up with is what I want you to, you can simplify this down a little bit. You've got ln of 2, and then plus 1 minus 1 cancels out. Ln of 1, as we've said previously, is 0. These series completely match up. So you can say 2 to the n over n factorial n minus 1 over n factorial n. They have the common denominator, so you can even simplify that further in terms of putting it into your calculator. Numerator here, n equals 2 to infinity. And remember, when you plug this into your calculator, most of you will have this as a function, as an option under your math button, that you will use the sum. If you don't, you have to go to your do sum and sequence, and then type in the function, parentheses 2 to the n minus 1. And then for factorial, you're using the math button again. And then you're going to go over to probability, type in factorial, and like that. So you should get the same answer as you got before. But if you didn't, please let me know. And I'm happy to help you with all of those. But the important thing here is to start with that and then make sure you're getting some practice on your calculator while also practicing this strategy for integrals and differentials, derivatives. Let me know if you have questions, and I'm happy to help.